to being done, so I want to go over each one. I'm just verbally going to go over each one. Take a look at your sheet. 1A, the answer is yes. It's Z is a group. We already know it's a group under plus, and it's a subset of R, and R is a group under plus. These were the first examples that Fraley showed you as an example of a group. So the answer is yes for A. However, B is not a subgroup because Z plus doesn't have inverses. If you take 2, for example, it belongs to Z plus, but -2, the additive inverse under plus, is not in H. So therefore, B is not a subgroup. What about C? What do you guys think of C? Yep, this one works. It's really interesting how they ask the questions. I love this. This is from that book I was telling you about. They asked you about 3n. It is indeed a subgroup because you find out quickly that if you add anything with multiples of 3 to each other, it still remains a multiple of 3. You find that 0 belongs in there, so it has an identity. All negatives are in there, inverses. So therefore, it is a subgroup. However, what about the next one? If you look at 3n plus 1, correct. It doesn't have an identity. If you add a couple things in there, it's not closed. Correct. Yeah, so it violates a whole bunch of them. Now, E and F are very interesting. I think whoever wrote this book had an interesting way to start twisting you. Z5 is addition modulo 5. It's these boxes. The objects in them are not actual integers. They are something else. So Z5 is not a subset of Z to begin with. They have different meanings, right? They're equivalence classes. Same with Z4. Z4 is addition mod 4, and Z8 is addition mod 8. So it doesn't make sense to even talk about H being a subgroup of G under addition. So for E and F, those are weird questions because they're not subgroups. So I guess they're trying to get you to think about what these things are and whether they look like objects from the original set. And I think that especially in undergraduate, when you first see them, you start thinking about them in that way. But they're not subsets of the original set. So in undergraduate abstract algebra, one of the first things you learn is what we call the subgroup test, where you realize after you start doing some examples, and when you did these examples, you realize that you really didn't have to show a whole bunch of stuff. You just had to show closure and that the identity and inverses are in there. So H is going to be a subgroup if, number one, it's closed, because you don't want to bump out of that subgroup and end up in the big group somewhere. Second, it's got to have the identity. And third, if H is in there, H inverse also has to be in there. And I noticed on the side looking at my chat box that you quickly wrote no identity, no closure, no inverse. So you already were kind of seeing the development of the subgroup test. So you don't have to show H is a group all by itself. You can easily just show that these 3 properties hold, and then it's a subgroup by just these 3 properties. And in Fraley's correct, it does. It does. Kristen, you're right. Once you have shown all that the inverse is in there, then E must be in there too. But you have to show closure first. Once you have closure and the inverse is in there, then you're done. And he doesn't call it the subgroup test. He calls it theorem 5.14. So I want to go back to the dihedral group of 4 and show you some more, a different representation, introduce you to permutation groups through this representation, and then look at a special subgroup. In Z4 is addition modulo 4. You're looking at the remainders of integers when you're dividing by 4. So it's not a subset of Z. And that's the problem. It's each one of the objects in Z4 are equivalence classes. That's not true for Z. So even before you go ask the question of subgroup, it's not a subset. Jeff, okay? I don't know how you looked at just so I have the boxes, but in Fraley they do talk about equivalence classes and relations. So the objects in Z4 are entire sets. The boxes are sets, and the objects in Z are integers. They're standalone numbers, they're not sets. So they're not even the same objects.